Go ahead, try to tickle yourself. Seriously, under your arm, your neck, the bottom of your foot. I'll wait, did you laugh? Probably not. Now let someone else do the exact same thing. Suddenly, you can't stop laughing. Same fingers, same skin, same movement, completely different result. But why? How can your own brain tell the difference? And here's something even stranger. The secret isn't your hands. It isn't your skin. It's a tiny prediction happening inside your brain before your fingers even touch your body. A prediction so powerful it has been helping humans survive for millions of years. And it might be one of evolution's greatest inventions. Imagine closing your eyes and reaching for your nose. You touch it perfectly. You didn't need to see it, because before your hand even moved, your brain already knew exactly where it was going. Every movement you make, your brain predicts it before it happens. A tiny part of your brain called the cerebellum constantly creates a copy of every movement you're about to make. It predicts where your hand will go, how fast it will move, and exactly what your skin is about to feel. Think of it like watching a movie you've already seen. Nothing surprises you anymore. Your brain treats your own touch the same way. Before your fingers even reach your skin, it already knows what's about to happen. So instead of reacting, it quietly turns the sensation down. Scientists discovered this by scanning people's brains while they tried to tickle themselves. The touch centers became much less active, not because they weren't touching themselves, but because their brains had already predicted every sensation. But everything changes the moment another person reaches toward you. Now imagine you're walking alone through a forest. Everything is quiet. The wind moves the trees. Then suddenly, something brushes against your arm. Instantly, you jump. Your heart races. Before you even know what touched you, your brain is already preparing for danger. Why? Because for millions of years, unexpected touch often meant something was wrong. A snake hidden in the grass, a spider crawling across your skin, a predator attacking from behind. Your ancestors couldn't afford to ignore surprise. The faster they reacted, the better their chances of survival. That's exactly why someone else's touch feels completely different. Your brain can't perfectly predict another person's movements. Will they touch your arm? Your ribs? Your neck? Will they stop or keep going? That tiny uncertainty changes everything. Instead of turning the sensation down, your brain turns it up. The exact same touch suddenly feels ticklish, not because your skin changed, but because your prediction failed. And that's something your brain never wants to ignore. But here's another mystery. Why are only certain parts of your body ticklish? Think about the places that make you laugh the most. Your ribs, your neck, under your arms, the bottom of your feet. Why those places? Because they all protect something important. Your neck protects major blood vessels. Your ribs protect your lungs and heart. Your stomach protects vital organs. Your feet keep you balanced while walking. For your ancestors, protecting these areas was essential for survival. So evolution made your brain pay extra attention whenever something unexpected touched them. Tickling isn't really about making you laugh. It's about making sure you notice. The laughter comes afterward. And that's why children are usually far more ticklish than adults. Their brains are still learning, still exploring, still discovering what is safe and what isn't. But one question still remains. If tickling is really part of a survival system, then why do humans laugh instead of running away? At first, laughter doesn't make any sense. If something unexpected touches you, why wouldn't your brain make you run away? The answer begins in childhood. Long before schools, long before civilization, human children learned through play. They chased each other, wrestled, pretended to fight, not because they were playing, but because they were practicing survival. Tickling became part of that practice. It trained children to react quickly to unexpected touch, to protect the most vulnerable parts of their bodies. But something else happened. They laughed. Scientists believe that laughter may have acted like a signal, a way of saying, "This isn't a real attack. I'm safe. The danger is only pretend." Think about it. If a stranger suddenly grabs your side, you probably won't laugh. You'll pull away. You'll become alert. But if your brother, your best friend, or your parent does the exact same thing, your brain recognizes they're not a threat. Fear instantly transforms into laughter. Because tickling isn't just about touch. It's about trust. Without trust, tickling isn't funny. It's uncomfortable. That's why we rarely tickle strangers. We tickle the people we feel safe with. And that simple difference tells us something incredible about the human brain. Go back to the beginning of this video. You tried to tickle yourself. It didn't work. Not because your fingers are different. Not because your skin is different, but because your brain had already predicted every single sensation before it happened. Every second of your life, your brain is quietly predicting the future. Not tomorrow, not next week, but the very next moment. It predicts your movements, your touch, your balance, even the feeling of your own fingers against your skin. Without those predictions, walking would be harder. Catching a ball would be harder. Even picking up a glass of water would become a challenge. The same system that helps you survive is the reason you can't tickle yourself. So the next time someone makes you burst into laughter, remember, your brain wasn't fooled by the touch. It was fooled by the surprise. And maybe that's the most incredible part of all. The greatest prediction machine ever created isn't a supercomputer. It isn't artificial intelligence. It's the one you've been carrying inside your head your entire life.